Welcome back to the series. In today's episode of Better Rockets, I'm going to be making one of the most common types of launch vehicle around today, an orbital rocket. These things are used to send astronauts and satellites into orbit. Almost all of the well-known rockets are orbital rockets. The Falcon 9, the Falcon Heavy, Atlas V, and even the space shuttles, although retired, are still orbital rockets. Today I'll be making my own and using it to get a satellite into orbit. So let's get started. There are lots of different types of rocket engine, but for the bottom stage I've selected a large solid-fueled engine, and for the top stage I've selected a small liquid-fueled engine. Wait, what's a liquid-fueled engine? A liquid-fueled rocket engine is similar to a solid-fueled rocket engine, but instead of using solid propellant, it uses liquid propellants. These can include combinations of substances like Carlox, a mix of liquid oxygen and kerosene, or Hydrolox, a mixture of liquid oxygen and liquid hydrogen, which are all highly energetic and explosive when ignited. The advantage of liquid propellants is that they allow for better control over the engine's thrust. Unlike solid propellants, which burn at a fixed rate, liquid engines can be throttled, stopped, and restarted during flight. This makes them ideal for powering the upper stages of rockets where precise control is essential, especially when you need to maximize efficiency while still packing a lot of power to escape Earth's gravity. Liquid-fueled engines are typically more complex than solid-fueled ones, requiring sophisticated pumps, plumbing, and cryogenic storage tanks for fuels like liquid hydrogen, but they offer significant performance benefits like increasing the efficiency of the entire system. By combining both solid and liquid engines, we get the best of both worlds: the raw power and simplicity of solid fuels for initial liftoff, and the precision and efficiency of liquid fuels for sustained propulsion. Now that the rocket is ready, let's get into space. Now that we have a path out of the atmosphere, we can fire our engines at the top of this path and get into orbit. But how do orbits work? Orbiting is a complicated process. You need to be going faster than 7,000 meters per second, or 66,000 miles per hour, which is incredibly fast. You also have to be above 400 kilometers so you don't hit the atmosphere and burn up. That's why getting into orbit is so much harder than getting into space. Now that we're up here in a stable orbit, we can release the probe to orbit on its own. Over the next few years, this satellite will gather invaluable data about the moon and stars, paving the way for us to design and build a moon rocket in our next video. That's it for this video. Like and subscribe and look out for episode 4. See you soon.